Hello, we are looking at problem number 2 found on page 229 of your textbook. This is in the section about proving triangles are congruent by either side, side, side or side, angle, side. Now, in the previous pages, it's talked about how to do this and what these particular ones stand for. Problem number 2 specifically is looking at side, side, side. Side, angle, side. So we're going to look, and it says, what other information do you need to prove that triangle DEF, which is this one right here, is congruent to FGD, which is this one right here. Okay. Now, if you look carefully, you see already that we've been given that EF is congruent to GD. Okay, those are congruent to each other. Now, we can look at the picture or just by the way that they are written in the particular congruency statement here, we know that if I say EF, that I have to say GD. Okay. Also, we know that DF is always congruent to itself because this line right here belongs to both the top triangle and the bottom triangle. But it's the same line, so it's congruent to itself. That's called the reflexive property of congruence. Now, if we know this, and let me mark this, we know that this one is congruent to itself, then if we're going to prove this by side, angle, side, then we've got to pick the angle that is between this side and this side, which would be this angle right here. As well as on the bottom, it would be between this side right here and this side right here, which again would be that angle right there. So what we need to know on this is this right here, that EFD is congruent to GDF. Okay, that's the only angle that it could be to use or to be able to use side, angle, side for proof. Okay. Now, let's look at the got it section here. On the got it, first of all, this down here is just showing you that if you really wanted to prove this length, you could take your compass, like we learned a little earlier, and mark from L to E, and then if that same compass mark goes from N to B, we'll know that those are congruent to each other. Okay? But that's all that that's really saying down here. Now, what we have been given in number 2 here is that this angle right here is congruent to this angle right here. Okay, now again, we're trying to prove this by side, angle, side. So since that is the angle, we need to know this side right here, and we need to know this side is congruent to this side because that is the two sides that are attached to that particular angle, and that's the only way that we could get side, angle, side. So we need to know that EL is congruent to NB. Yes, I'm sorry. NB. That's one of the things we would need to know. And again, you could use that by using this right here. You could use a compass and prove that those are the same length. And of course, just like we did in the example, LB is going to be congruent to LB, and that's due to reflexive property because any side, even though it belongs to this side and this side, this middle part right here is congruent, of course, to itself. So that would be the two pieces of information that we need, and those would be easily proved as we go through this. Okay. That's how you prove that triangles are congruent to each other by what we refer to as side, angle, side. Okay, I hope you the best.